3 times
z plus 2
Am I done?
equals 0.
You can tell by my face how many times Jin said left answers. Right? Oh, I forgot that. But there you go, done. Unless you want to go and simplify it. But that's fine. That describes the plane. That's the equation of the plane. Equation's got to have an equal sign, right? Okay. Well, we said that was too easy, right? Let's do a challenging one. I'll leave this up here for our notes. I want you to try this one. Great job on that. The points are, this is like 23 in a practice set. Which one's this like in a textbook? This is like number 31 from section 12.5. It's also like number 32 from textbook. Heck, I should do number 32. Nah, I'll make up points like this. Here's P. 0, 1, 2. Q. 2, 4, 4. R. 1, 0. I'll make this a 3. 3 points. 3 points on a plane. Can you find the equation of the one? All right. Let's start out. What do I need?
Normal.
I need a point on a plane. I got 3 of them. Does it matter which one I pick? All right, I'll use P. Pick the first one. But now I'm stumped. Now here's a problem. Drawing a picture sometimes helps us out. Here's some plane. There's 3 points on it. Right? I've got one of the points, but I need a vector that does what?
It's normal.
Like that.
Oh,
Any
so
suggestions? Oh, I just heard it. He's got the idea. Get 2 vectors. So you're onto this. Outstanding. He gets first get 2 vectors in a plane from your points. Those 2 vectors will be in the plane. And then he says, take the cross product to those 2 vectors, because the cross product of 2 vectors is what? Perpendicular to the plane, right?
Mm-hmm.
Yep. And the markers. That helps just seeing it. You're like, he's saying get 2 vectors in a plane from those points. We can do that easily. And then when you cross these 2 vectors, give me that textbook. You cross these 2 vectors, you get a vector that is what? I need a third vector. Here. Bing. It's going to be perpendicular. And that's what we'll do. So first thing is, everyone, before we accidentally cross points, you can't cross points, we need vectors. What is PQ? What's PQ?
2, 3, 2.
2, 3, 2? Okay, what's PR? Tip minus tail.
PR
Negative 1 and what? Now when you cross those, oh, here we go again.
No, PR is.
Did I mess up PR?
Yeah. Oh, no, it's equal. Working 1.
We're good?
Mm-hmm.
Hey, cross them. Remember how to do this? Wipe out the first column. Here you can put an IJK if it helps. And just put these vertical lines. We're getting the determinant of this matrix right here. So wipe out the first column. 3 times 1 minus 2 times negative 2. What's 3 minus negative 2? Hey, do the third component. Wipe out the third column.
Mm-hmm.
What's negative 2 subtract 3?
25.
Now remember, what do we do
Put
on this
negative-
middle component? We never do it in the other.
Negative signs.
Negative, just do the same thing. Middle column, wipe it out. 2 times 1 minus 2 times 1, change the sign. So what's negative 2 minus 2? So negative of the 0 is just a what? 0. Hey, there's our normal vector. I always double check this, because when with my eyes, I could have been looking at the wrong one. Column or something, let's double check this. Is this dot product with this 0? Is 5 plus 0 plus negative 5 0? Check the other one. Is 10 plus 0 plus negative 10 equal to 0?
Mm-hmm.
Got it. So this is that normal vector. 5, 0, negative 5. Which point am I using? I just thought I used one. Doesn't matter which point you pick, right? Here's the equation of the plane. It's going to be 5 times x minus 0 plus 0 times y minus the 1? plus,
-5 times
I'll erase this now. -5 times,
z minus 2.
all done? Equals 0. Or if you want to clean it up, what's it look like? It might look a lot better. 5x minus 5z. Oh, it looks way prettier. Whoop, that's a z. Plus 10 or minus 10?
Equals,
Equals negative 10?
yeah.
Do you want to even prove that if you want? I mean, 5, 5, and 10 or what? 5's a factor of 10. Divided 5 on both sides? Okay. Or x minus z equals negative
2.
2. Now, how can I check this?
Just plug the right number.
Like, I mean, before you turn in your test next week, check this point, but I wouldn't stop there. Check this
Okay.
point and check this point. All three work. There's no way you messed up. Now, when it's happened where a student had 2 of them work and the other one didn't, that means they made a slight error somewhere. And they spent like 45 minutes trying to find their error. You know, just kept doing some silly mistake or whatever. But that one is 1 minus 3 negative 2, check. Is 2 minus 4 negative 2, check. Is 0 minus 2, oh, this is the equation at point. Is that what it goes on? So that's probably as challenging as they get, really. You're like, oh, how do I get the, I get 3 points? You knew to find the cross product of 2 vectors. That was really good. Any questions on that? Hey, let's do a problem that involves planes and lines. All right?
We could have done it in dot products, right? Because in dot product they're also 0. If they're 0, we could have done this one, right?
In terms of the,
Normal, final normal, orthogonal.
between those 2 vectors?
Uh-huh.
Yeah, but remember what happened with this problem? We never had this first.
Okay, got it.
Yeah. But he had, what he realized with the 3 points,
Uh-huh.
he goes, all right, you have 3 points on it. He goes, get 2 vectors in that plane and then cross them. Cool.
I understand, yeah.
And when I'm going to give a problem that's out of the textbook that relates planes and lines, this is the question. It's on page 824. Can you find a line to the point 106 and perpendicular to the plane x plus 3y plus z equals 5. Can you find a line to the point 106 and perpendicular plane x plus 3y plus z equals 5? Hey, anybody want to know what problem I just picked again? This was number 5 from the textbook, section 12.5. So this problem is involving lines and planes, right? But we are looking for a line. Let's go back to what we need. I need a point on a line. We have that?
Yeah.
Check. What kind of vector do I need? Because I need to find the line. So I need to find a vector that is
Parallel.
parallel to our line. I'm lost. I don't know what to do. I'm telling you what helps. Just make a little picture. Start looking at this and see what you got. All right, what? There's some plane here. What's the equation of plane? I'll just write it. X plus what?
3y
Plus
plus z.
z equals 5. Okay. I'll find a line to some point. Okay, there's some line that's what? Just going like this. And it's got to be perpendicular. I'll put the line over here. There's the line. It's running what? I'll put it 90 degrees out here. There's the line, and there's some point on it. What is it? 106. Daggone it. If I could only find a vector that goes like that. Great eye. Ellen, he says, look carefully at this plane. Look what I'm looking for. We want a vector that runs parallel to that line. He says, hello, how are planes described? Planes are described by normal vectors. And he's looking at these numbers. Which one of these numbers in here represent that normal vector? The 1 and the 3 and the 1. The 1, you want to see that? I'll put 90 degrees right there. The 1, 3, 1, who cares about the 5? The 1, 3, 1 represents the normal vector to the plane. Is that vector parallel to our line?
Mm-hmm.
We got it. Let's go fill it in. We get I read it vertically. Oh, want to write my parametric equations? You can write it as a vector if you want. X equals y equals 0, z equals, what's the point? 1, 0, 6, plus, 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 t, 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 and what's in front of these t's? A 1, a 3, and a 4. Oh, what's the last number? 1. Coefficient of the z. Parallel vector. You got it. These are the parametric equations of the line, by the way. Some of you may have written that as a vector. A vector equation of the line. With parameter t. But it has to have that parameter. You don't have to always use t. You could use s, m. The book always uses t, so do I. Great job. A couple other things. This is problem number 45 from the textbook. Can I erase? Some with lines and planes. Or I can erase. Cool. This is number 45 in the textbook. Something with lines and planes. This is what they wrote. They gave the parametric equations of a line. X equals 3 minus k, y equals 2 plus t. Remember, I'm writing this vertically. A lot of times it's written horizontally with commas between them. And z equals 5t. So I'm going to agree these are the parametric equations of a line.
Mm-hmm.
Here's the plane. So I'll just write line. Parametric equation of the line. Here's the plane equation. X minus 2y plus x minus y plus 2z equals 9. Okay. There's the line, there's the plane. The question. Find the point where the line intersects the plane. The question again, this is number 45 out of the textbook. Find the point where the line intersects the plane. So once again, we're problem solving, going, how are we going to do this? So we're all thinking. I always draw a picture. It helps me start thinking about this, right? All right, there's the plane, right? There's that thing. And then the line maybe does what? At some point, the line's going to hit this plane. We're looking for the exact point that happens. But throughout all of mathematics, have you noticed a common theme when it comes to the word intersection? Right before your class, I was teaching Calc 2. We talked about two curves intersecting. We talked about, the substitution rule. Take one variable from one equation, substitute in the other, and you can find where they intersect. So if we're trying to find where a line intersects a plane, then this definitely involves some kind of substitution method. Any suggestions?
Yeah, so x, replace them like 3 minus t.
Take this, put it there,
Uh-huh.
substitute it. Take this, substitute it where?
Y.
There. Take this, substitute there. Whoop, let me get pointing to that z. And then we're going to solve for what letter? Man, you're good. 3 minus t minus, be careful of the sugar probably, 2 plus t plus 2 times 5t equals 9. Great idea. All right, what is all that? Minus t minus 2 minus t plus 10t equals 9. Like terms?
T.
3 minus 2 is?
1.
1 minus 1 plus 8t equals 9. Okay, you're kidding me. Was this easy? And when I take 1, I subtract 9. What's the t?
1.
Okay. Maybe a little bit too easy. T is what? Hey, don't leave the answer like that. One more step. They said find the point where the line intersects the plane. What do I do with this? Put it right back in the parametric equations. You'll get your x, y, and z point. Let's do that. What is that real point? So when it's at t equal to 1, so I'll say it's at t equal to 1.
3
The
minus
point
1.
is 2, 3, and 5. That's the point. That's the answer. That's the point. Hey, I apologize that, highlight this in your notes. I didn't put one of these on the practice set. I should have. It's a good problem. So would you just make a note of that? Yeah, it's a good problem. Just because it really involves, we're thinking about lines and planes, and we took an old math skill of intersection. How do we find where two things intersect each other? But I didn't have that on the practice set. A great problem. You know what to do. Cool. Hey, a couple more things before we go on to 12.6, which is really cool with the other surfaces, is if I give you two equations of planes, how can we tell whether or not they're parallel to each other? These are two equations of a plane. All right. How can we tell whether these planes are parallel or perpendicular or neither? So let me look at this one. All right, x plus 4y minus 3z equals -1. Does that look like the equation of a plane? Right? That's a 1. X plus 4y minus 3z equals 1. The other plane equation is -3x plus 6y plus 7z equals 0. The question, are these planes